In number 4, we are required to find the gradient of this function at the given point. So to do that, we shall start by finding the derivative of this function. So dy over dx, in this case, will be equal to, now because this is a product of two functions, we shall apply product rule. So basically 3x multiplied by the derivative of cos 2x plus cos 2x multiplied by the derivative of 3x. Now, if you notice here, you can see that here we have a function inside the other function, which implies that we shall apply chain rule when we differentiate this portion. So dy over dx here will be equal to 3x multiplied by, now the derivative of inside, which is derivative of 2x, will be 2. Derivative of cos is negative sine, and our x happens to be 2x, plus cos 2x multiplied by derivative of 3x is just 3. And then we put these results together, so that will be equal to negative 6x multiplied by sine 2x plus 3 cos 2x. Okay, now once we have our dy over dx, which is that, our second step will be to find the gradient of the curve at x is equal to 5 pi over 6. So we can say that at x is equal to 5 pi over 6, gradient of the curve can be found by plugging 5 pi over 6 in the derivative of the gradient function. So basically that will be equal to negative 6 multiplied by 5 pi over 6 multiplied by sine of 2 multiplied by 5 pi over 6 plus 3 cos into bracket 2 multiplied by 5 pi over 6. So this will be equal to negative 5 pi multiplied by, now 5 pi over 3 is same as 300 degrees, and I'm working with degrees because most of you find working with degrees much easier than radians, but you can still work with the radians if you're fine with that. Anyway, so that will be 300 degrees, and then this will be 5 pi over 3 again is 300 degrees, so 3 cos 300 degrees. Now we can convert these angles in terms of acute angles, so because we want to use special triangles to find this. So this will be negative 5 pi multiplied by, now sine 300 is same as negative sine 60 plus 3 cos. Now cosine of 300 is same as cos 60 again. And the reason why I am writing this in terms of acute angles is because I plan to use the special triangle. So if you have 2, 2, 1, 1, and 3, and you know that this is 60 degrees, then we can be able to find, because we know now that sine 60 will be equal to root 3 over 2, and cos 60 will be equal to a half. We can be able to use these trig ratios from special triangle to simplify this part. So this will be equal to negative 5 pi. It's actually 5. So 5 pi into bracket. Negative 60 is negative root 3 over 2 plus 3 multiplied by cos 60 will be equal to a half. And then if you simplify this, that will be equal to 5 pi root 3 over 2 plus 3 over 2. And that's basically how you work out that question. The second question, the fifth question here, you have find the derivative of this uh, function. Now again, if you look at this, we can see that this part here can be written, can be simplified. Uh, so this is same as second of um, x squared, and then this portion here, if you remember trig ratios, this will be equal to trig identity, sorry, this will be equal to cosine of x squared. So using trig identities, we shall have f of x being equal to so this, the first expression as first bracket is same as second of x squared, and then second bracket is same as cosine of x squared. Now second of x squared is same as 1 over cosine of x squared. So we have 1 over cos x squared multiplied by cos x squared. Now this cancels, so this will be equal to 1. So basically our function here we have is f of x is equals to 1. So which means the derivative of this will just be equal to 0. Okay, moving on to number 6. So in number 6, you are required to find the gradient of this function at x is equals to 0. So because this is a product of two functions, we shall apply product rule. So basically, we have dy over dx will be equal to e to power x multiplied by the derivative of second of x plus second of x multiplied by the derivative of e to power x. So this will be e to power x multiplied by second of x. Now the derivative of second of x is uh, from the formula that I gave you earlier. That will be equal to second of x multiplied by tan x, and then plus second of x multiplied by the derivative of e to power x is just e to power x. So basically, if you simplify this, this will be e to power x, second of x multiplied by tan x plus e to power x, second of x. Now, at x is equals to 0, gradient of the curve will be equal to e to power 0, second of 0, tan of 0, plus e to power 0, second of 0. E to power 0 is just 1. Now, second of 0 is same as 1 over cosine of 0. And then tan of 0 is same as sine of 0 over cosine of 0. Plus, here we have 1 multiply 1 over cosine of 0. Now we know that sine of 0 is 0 and cosine of 0 is 1. So this will be equal to 0 plus 1, which is just equal to